You are videotaping a race from a stand 132 feet from the track following a car that is moving at 180 miles per hour or 264 feet per second as shown in the figure. How fast will your camera angle be changing when the car is right in front of you? And what about a half second later? Okay, let's see what can we do here. And I'm here with the camera and I'm looking at this car that is racing there. Okay, but this one form a right angle triangle, right? So I think we can model this using trigonometry. Let's name the distance between the car and where I stand here as x, like this. And we already know that this is 132 feet, right? So using trigonometry, this is the opposite side and this is the adjacent side. Opposite and adjacent is tangent. So we can write this as tangent of theta. And that will equal to x, which is the opposite side here, divided by the adjacent side. So I'll have x over 132. Good. But then I can take the derivative for this both sides, right? With respect to time, okay? And the derivative of tangent theta is secant square, right? Secant square of theta. But this is the derivative of tangent theta with respect to theta. To get it over time, we need to multiply it by d theta over dt, right? Because of the chain rule. Good. And then that will equal to, I think we have this one here. The derivative of x is dx dt, but 1 over 132 is just a constant. So I'll have 1 over 132 and then multiplied by dx dt. Okay, now I want to move this secant square to the right hand side, so I can isolate for d theta dt. Why? Because the question asking us for how fast your camera angle, which is d theta dt. And then we will have this one here, 1 over 132, and then multiplied by secant square of theta. Right? And then multiplied by dx dt. But remember that, let's put it here, 1 over secant square of theta, that will be equals to cosine square of theta, right? Okay, so I can rewrite this equation here into like this. So I have d theta dt, and then that will be 1 over 132, and then I will have cosine squared of theta, and then multiplied by dx dt. But look at this cosine square of theta. Remember that cosine is the adjacent divided by hypotenuse. And if we see this right angle triangle here, the hypotenuse here will be the square root of x squared and then plus 132 squared. And we have the square root of it, right? So I think we can plug this here into cosine of theta. Okay, so let's rewrite that first. So I'll have dt over d theta over dt. That will be 1 over 132. And then multiplied by cosine square of theta. Remember that cosine is the adjacent. Okay, so I'll have 132. And then divided by the square root of x squared plus 132 squared. So I have x squared plus 132 squared. Okay. And then multiply that by dx dt. And this one is square, right? Okay, now let's simplify these things more. So I will have d theta dt, and that will equal to 1 over 132, and then multiplied by this one. So I will have 132 squared, then divided by x squared plus 132 squared, and then multiply that by dx dt. Good. Okay, now we can cancel out this 132 and this 132. So in the final form, okay, maybe let's simplify this. I need some space here. Okay, now let's simplify this. So I will have d theta over dt, and that will be 132 divided by x squared, and then plus 132 squared, and then multiplied by dx dt. Okay, that's good because we can just plug the number in, right? But we need to see what situation that we need to find the number that is plugged in. Okay, we know that this car is moving on 180 miles per hour, or we are given the conversion here, which is 246 feet per second. And because this 132 is in feet, I think I just use this one here. So I will have dx dt here. Dx dt, that will be 264. 264, and the unit will be feet per second, right? Dx is in feet and dt is in second. Good. Okay, now when the car is right on front of me, okay, when the car is in front of me. Okay, when the car is in front of me, that means that the car is moving there, right? But now that is here, the car is here, and it is still moving there with this speed, right? And what does that mean? That means that this x here, right? This x is equal to 0, right? So I will have d theta dt when our x is equal to 0, because the car is here. So we have no x here. The adjacent and the hypotenuse will be the same, right? And so I will have this one. So I will have 132 divided by x squared, which is 0, and then plus 132 squared multiplied by dx dt. So I will have 264. 264. Good. And I will have 132 divided by 132 squared multiplied by 264. Okay. And this will cancel this square here. And 132 and 264, I think I will have cancel into 2, right? And so I will have the speed of our camera here, the angle, which is 2 radian over second. And that is the answer for this question here. I will have 2 radian over second. Okay, and now let's answer this question a half second later. Okay, now let's do a half second later. A half second later, meaning that t is equal to 0.5 second. Right? And remember that we can calculate this x here using kinematics, right? So I will have x is equal to dx dt, which is the speed multiplied by time. And our speed here is 264 multiplied by t, which is 0.5. And I will have 132. And the unit here is feet. Okay. So now we can just plug this x is equal to 132 feet into this formula, right? So I will have d theta dt when x is equal to 132. Okay, now let's plug that in. So I'll have 132 and then divided by 132 squared plus 132 squared and then multiplied by dx dt, which is 264. Okay, now let's do the sum simple arithmetic. So I'll have 132 and then there are two 132 squared, right? So I will have 2 multiplied by 132 squared and then multiplied by 264. Okay, what can be cancelled? 132 and this square, and then 132 and this 264, that will be 2, and this 2 can cancel out with this 1 here, so I will have 1. So here I will have d theta over dt is 1, and the unit is radian over second. So a half second later, my angle speed will be 1 radian per second. And that is the final answer for this problem. Hopefully I did not make any mistakes during my calculation. Thank you for watching. See you in the next video. Bye bye.